And of course that would be pretty disastrous if you did that as a network render, because obviously as you went from frame to frame you get a flicker as you got these basically two different simulations playing back. So the traditional method for getting around that issue is to actually bake your particles into memory or onto a hard disk, and then in that way you can then share that over network and do a render, and you don't get any disparity between any nodes in your render farm. They all render the same image, they all render the same simulation. Now, one thing to bear in mind with a cache is that it does use memory, and this usage can be quite substantial with particle systems that are using millions of particles per frame, or even thousands. Now, always remember this when you're using a cache, as it can easily run away with the memory in your PC, and it can cause pflow and therefore Macs to crash. Hopefully this will be remedied in the future with a disk-based cache, i.e. one that instead of writing the data to memory, instead it writes the particle data to your hard disk or a network drive. And this solution would be slightly slower when you're working with interactive playback, but it's a solution that's only really limited by mass storage space. And these days that would mean it's very easy to buy drives with 100 gigabytes, 200 gigabytes of data on it. So if you've got a shot that needs a huge amount of particles and is very long and would require let's say 4 or 5 gigabytes of memory, hopefully in the future there'll be a cache written which will, instead of, as I said, caching to memory, will actually put that out to disk. For now, of course, we're stuck with the memory cache, which is very good, but obviously you're limited to the physical amount of memory you can put in your PC. So to show the memory usage, I'm actually going to clear out the cache using the clear button here. You can see I've set a memory limit here of it's 14,000. Actually, it's 4,194,130,4K. Now, if I go in here and put in 99999, press return, you can see it goes back to that value. So that's actually hardwired into the system. And I think if you actually take that value, which currently isn't really accessible with within Windows, but it will be when, for instance, you run Macs on a system with Windows XP 64. Obviously on a 64-bit processor. The default value is, I think it's 100,000, which works out to be roughly 97 megabytes of RAM. And that's obviously quite a tiny value by today's standard. So one of the first things I do when I'm working with the operator is to actually, just as I've just done, put in lots of 9s, press return and set it to its maximum value. Obviously you could work out what 2 gig was. Most PCs these days, workstations, will have 2 gigabytes of RAM. You could work out a 2 gig value and put that in there as your standard value. And obviously in that way you wouldn't cause the operator to obviously run away with the memory too much. Okay, so to see the memory usage, I've just cleared the cache operator. You can see that I'll just quickly run through this this memory group here to give you an idea what it does. The limit we've just discussed, that actually limits how much RAM the operator is allowed to use in total. Then you've got a total and a current frame. So the total is how much memory it's actually currently using. And then you've got a current frame value, and that's how much memory the current frame of the simulation is going to cause, is actually going to need to be stored in memory. So as you play the simulation, the current frame value will obviously fluctuate as the particle count increases, and the total will obviously go up in a linear manner based on the size of the current frame. Obviously if you have very, very large current frame values, this total value is going to go up very, very quickly. So you've got to be aware of this. And obviously if you set in a 2 gig value here and this approaches that value, it's probably a good idea to stop your flow and reduce the number of particles, otherwise you're going to get a crash. So to show that in action, I'm just going to actually bring up Task Manager. Here it is. Now some people have said that Task Manager isn't that accurate in its reporting of memory. But in Windows XP Pro, which is what I'm actually running here, it seems to be quite accurate. I generally get crashes when I'm using Macs when I get up to about 2 gig. And that's how much memory my PC has. So it pretty much indicates that it seems to be quite accurate. You can see we're flying along here at the moment using 577 megabytes.